So thank you welcome everyone. Um, I'll present our Bucky Lab projects. We are group 9. We're working on storage system. We think that harvesting energy is really important, and as we saw, it's being taken care of. But we think that storing energy is really a big task, and and we wanted to address that problem. So we wanted to address by coming up with a solution that would store energy at the peaks, so in summer, and releasing that energy in winter. We would also wanted to make it visualized, so we would bring more awareness and maybe even interact with the storage. And during the process, we defined that our storage would need to be a heat storage, as we took Netherlands as a starting point. And we realized that 82% of the households in the Netherlands were using heat instead of electricity. So we, at the end, switched to heat. So we first started with gravitational storage, which was a big failure, as we saw that it wasn't efficient enough, it wasn't dense enough. As you can see, as this example, if we take a 500 kilos at 15 meters high, it would only have enough power to light up one LED for 2 hours. And in our case, the 10 kilowatt hour of consumption, average consumption, would be 74 cubic meters of concrete. So we had to somehow start over again, and by looking at different storage systems that exist in innovation. And we come up with a big table in which we set up our hard criteria, such as efficiency, visibility from the facade, and lifespan, and we come up with a solution. And we actually improved a lot. As you can see, there's the little family under the block, and we pass from a 74 cubic meters to a 4 cubic meter solution, which is a chemical solution, which stores heat. The system is really easy. It has some water that's released in the salt tank that produces an exothermical reaction, and this produces heat. Through heat exchanger, the water can be used for several usage. To dry this and therefore store the energy, we dry up the salt by using solar collectors and dry the salt. After understanding our system, we had to go through design, and we had countless whiteboards, sorry, and we came up with 3 solutions, which mainly differ in scale. The first one is the entrance. The second one would be used more in the household scale, and the last one would be more at the neighborhood scale. And that's the one we chose. And we actually wanted to also use the ideas from the visualization from the per building idea. So then the building week started, and we went into formalizing the previous ideas into a big brainstorm of models, and to find the perfect shape. And we come up with another big table, in which we also crossed with our hard criteria, and we came up with this solution. The one is highlighted, and we further developed with taking care of the structure, the piping system, the connections, how the different systems will be connected with pipe, and we altogether drove more than 30 meters during this first week of the building weeks. So this is the evolution of our understanding of our system, in which we can see that during these last 5 weeks, we really informed our system, giving everything a purpose and a form, in which you can see that one column of the system is the amount of energy that one family uses per year, in which you have a water tank that could visualize the level of the battery. And the overall system looks like this for a funnel project, in which each column, which represents one family, would be arrayed and could be rotated in such a way that you can produce more shapes. Such as these ones. And their big ideas was to produce pavilions that could interact and adapt with each typology of patios, as the main market segment would be applying it in the big social housing patios that have no space, the no space appropriation, and this space interaction could be further developed with building some stairs and some high points to have some visibility for the people. Overall, we are really happy about our project. We think it's a very bold design, and it tackles some interesting problems. We are a bit reluctant though, considering the visualization and the space interaction, as we didn't have so much time to talk about it and to really give shape to every ideas that we had. Although we had a lot of ideas, we had a pretty good attempt with LEDs, even though we didn't thought it was sorry. Although we thought it would produce the result that we wanted. So I will give the floor to Job, that we continue with research and innovation.
You're muted.
We have 24 seconds left. Thomas, maybe you can explain this?
Yeah, well, yeah, maybe I will. So the idea was to study the width of the pipe, that during the different period of the year, we have different harvesting potential of the solar collector. And the idea was to fine tune the width of the pipe to have the good flow rates through the pipes in order to lose as less heat as possible. And the idea would be to tackle all of these variables, such as flow rate, velocity, and pipe width, and to optimize the heat loss. And the experiment would be to boil water to have the consistent water inputs, and to pump it with an adjustable flow rates in order to and test it with multiple widths of pipes in order to test different pipes and see the outputs. And the outcome would be to fine tune in order to have great length of piping. As our system, the main downflow would be to have that the system will have a lot of pipe going in large distance, and we need to come back. And I think that's it.
All right, thank you, Thomas.